Hello everyone, in this video we're going to be making a Slayer exciter or Tesla coil. Well, to me there isn't much of a difference except that the Tesla coil has a sphere on top and the Slayer exciter has a pinpoint. I started by cutting a 400mm length of a 50mm PVC pipe, but you can use a smaller pipe. I'm using a bigger one because the secondary wire I'm using is 0.5mm, which is quite thick. Then I drilled a hole in each end about 15mm away from the edge. This is so I can tie in the secondary coil. Now we need to tie and secure the end of our wire to a PVC pipe and start the laborious winding and winding until you reach the end. I'm sure there are other ways to do this, but this is my first one, so I wanted it to be perfect. You got to try and make sure that there are no gaps in between the wires. Then I sprayed the coil with some anti-corrosive spray. This was in the hope that the coil will never come undone. Then I insulated the secondary some more with some insulation tape, as I don't want the secondary to arc onto the primary coil, because I'll be using uninsulated refrigeration pipe. I thought that a larger refrigeration pipe will be better, but later realized that ordinary house wire works better. Anyhow, you need about 4 to 8 turns of the primary coil. Then we glued the PVC pipe to some perspex. I think they're actually made out of the same material, as a PVC weld bonds the perspex and PVC very well. Then I drilled a small hole for one end of the secondary coil to go through, as I don't want any part of the coil to touch the primary. Then put some more insulation tape for safe measure. Okay, so now that we got our primary and secondary coil made up and glued to a platform, we can get onto the circuit diagram. Now this is a circuit diagram I've got off the internet. You can get a few of them off there. Alright, so we're going to start off with, this is 3 9-volt batteries connected in series. It's going to be 27 volts. We're going to use a MOSFET. Here's our MOSFET. And we're going to use a 10k ohm resistor. I'm just going to add in a switch. So that's just going to cut the power supply like that. Alright, so let's solder all this together and see how this works. Okay, so let's just start gluing all our components to this platform. So we need a bit of super glue. Let's glue all this together. I'm going to use a heatsink for the MOSFET because the MOSFET gets really hot. Okay, so we're going to connect the collector to the primary coil, and I've got this crocodile clamp onto the primary coil, and we're just going to solder that onto the collector. Always remember to take the enamel off your wires. Okay, so then you get the base going to your secondary coil, and I've got another crocodile clamp onto the secondary coil, and I'm going to connect this to the base of the MOSFET. So let's do that. Okay, the base is also connected to a resistor, so let's add in this resistor. And then the resistor will be connected to the positive of the battery terminal, so let's do that. Okay, then we're going to connect the one cable here to the switch. Okay, so now all we need to do now is connect the emitter to the negative part of the battery, which is over there. So that's what we're going to do now. And then we're going to connect the negative right over here on this side, the transistor, which is the emitter. There we go. Our circuit is complete. Then you can drill a hole into a 50mm end cap and add a screw. This is what you'll attach your secondary coil to. And there we have it, wireless energy transmission of a Tesla coil. I was hoping for high voltage sparks to be spewing out the screw, but I think my secondary coil needs more wounds. I hope you enjoyed this video and will build your own better Tesla coil. Until next time, thanks for watching.